Okay, good morning, everyone. Today we'll start with the topic of limits. In this topic, the first thing we are going to see is a convention like x tends to 2. Okay, we will see what is the meaning of this statement. So for that, we can consider a number line. So on the number line, I can have something like -1. This is 0. This is 1, 2, 3, 4. So this statement, that is x tends to 2, what does it mean? It means that the value of x is approaching 2. It is coming closer to 2. So if the x values are somewhere here, okay, so this is the x value or the value that x is taking, and it is coming very, very close to 2. Okay, so we will say that x is approaching 2 from the left side, and that is given by this a slight negative on top of it. It is also possible that x is approaching 2 from the right side. So these are the values that x is taking. Now that is indicated by x tends to 2 plus. It is coming or it is approaching to 2 from the right side. So the numbers can be something like x equal to 1.99. Here it can be x equal to 2.001. Some number which is very close to 2, but it is not equal to 2. Okay, so one thing we need to remember, that x will never be equal to 2, but x will come very close to 2. Okay, so that is the idea of x coming closer to 2. It is also written as when x is approaching, say, a number 2, then x minus 2 modulus is less than a very small value. Okay, so delta is a positive value. Okay, so over here, I can denote delta by showing you something. Like suppose this value can be called as delta. So this is the value that x is taking, and x minus 2. Okay, and similarly over here, this can also be represented by delta. So delta is always a positive difference, and that's why you can see there is a modulus sign over here. So what I'm trying to tell you, that x is coming very, very close to 2, but x is not equal to 2. So we can think of something like x closer to 0, or x becoming infinite. That is also one concept. I will show it to you with the help of GeoGebra over here. So this is a polynomial that is created. Okay. And this polynomial right now has some number of sides. We can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. And here I'm increasing the number of sides. Okay. So you can see that the number of sides are increasing. As I increase this, so now you can see that the length of the side is this, which is smaller than this value. So as the length of the side is approaching 0, the number of sides are approaching infinite. That is the logic. And as I keep on increasing this, you can see that it close to become a perfect circle when the number of sides are too many. The second point that students should understand, that there is a function. Suppose this is 2x minus 3. So when you're doing f of 0, so you're plugging in x 0. So the answer to this is -3. If you're finding f of minus 2, so this is 2 into -2 minus 3, that is -4, -3, that is -7. So this is the idea that everyone should be aware about, that what value a function takes when x is so and so. X square minus 5x plus 6 upon x minus 3. Okay, I'm looking at something like this. So now that you know what this means, I'm asking a question, that as x approaches 3, what value does f of x approach? Okay, so this is a question: as x becomes closer and closer to 3, what value does the function approach? Now I have a way of writing that, and this is limits of x approaching to 3, x square minus 5x plus 6, and x minus 3 is equal to what? Okay, so whatever I've written in words, the same thing is written over here, and it is read as limit of the function as x approaches 3 is, like, it's a question mark. It is asking us to find the value for that. So in this, we are going to take the different values of x and say approaching 3, it can be like 2, so 2.5, 2.9, 2.99, 2.999. Okay, so these are the values that x take. And so what will be the corresponding value that the function will take? Okay, we can check that if it is giving us the correct answer. So 2 squared minus 5 into 2 plus 6, and this is 2 minus 3. So this is 0 over minus 1, that is 0. So it's giving us the correct value. So here what you see is the value of x is approaching 3, then f of x is approaching what? As x approaches 3, I'm calling this as from the left hand side. What do you think is the function approaching? Is it approaching a number? So it is approaching a number 1. Okay, yeah, correct. So now if I have to check as x approaches 3 from the right hand side, this function will approach what? Let us try that. So here again, students, as x approaches 3 from the right hand side, the function is approaching 1. Okay, so here I can see that it is approaching 1. So now how do we represent it? So we write it like this, which is called as the left hand limit. So limit x tends to 3 negative f of x is equal to 1. The right hand limit x tends to 3 plus f of x, it's equal to 1. So both are the same, okay, in this particular case. So therefore, we have the left hand limit equal to the right hand limit equal to 1. So therefore, we can say that limit of the function, which is x square minus 5x plus 6 upon x minus 3, exists and it is equal to 1. Okay, so I repeat again, the value that the function approaches as x approaches 3 from the left hand side exists and it is equal to 1, and it is called as the left hand limit. The value that the function approaches when x approaches 3 from the right hand side exists and it is equal to 1, and it is called as the right hand limit. And when do we say limit exists for a function as x approaches, say, a? We say that it exists only when the left hand limit exists and it is equal to some value, the right hand limit exists and it is equal to the same value as the left hand limit, then we say that the limit to the function exists. So in this image, we have to answer this question, that limits x tends to 2, f of x is what? And what is the graph showing you over here? This is f of x, okay? So as x approaches 2 from the left hand side, you can see that the function is approaching 1. Okay, so let me write it down here. The left hand limit is equal to 1. Then as x approaches 2 from the right hand side, the function again is approaching 1. So I will say that the right hand limit is equal to 1. Are they equal? The answer is yes. And what are they equal to? They're equal to 1. So answer to this question is 1. Then what is the value the function takes when x is equal to 2? You can draw a line from 2, and wherever it intersects the function, you take it sideways, and that value is 1. So this is answer to this question. I can call it as part A. Part B, again, they are asking us that what is the value of limit of the function when x approaches 2. So again, I'm repeating the explanation. As x approaches 2 from the left-hand side, the function approaches value 1. So the answer is 1. Right-hand limit, as x approaches 2 from the right-hand side, what value does the function approach? The answer again is 1. So are they equal? They are equal. The left-hand limit and the right-hand limit are equal. So therefore, the limit of the function exists, and that is equal to 1. So again, I'm repeating what we discussed just now, that the left-hand limit and the right-hand limit has to be equal to the same value. And then we say that the limit of a function exists. Now the question arises is what is the function value when x is 2? And here you can see that there is a gap. It is called as a hole. So when x is 2, the function doesn't point to anything. So the answer is do not exist or does not exist. Okay. And I have told you when x is approaching 2, we are not worried about what value 2 takes. Okay. We are just concerned that x is coming closer to 2. We are not reaching 2. We are not making x equal to 2. We are just worried about what happens as it becomes closer and closer to it. As x approaches to from the left side, right side, the function approaches value 1. So the limit is 1. And what is the value the function takes when x is 2? So you can see that the function takes value 3. So 3 is the answer. Does the function exist? It does. And it is equal to 1. Okay, all the graphs are same. So it's not specific to any particular graph. If this is the question, x tends to 3, what will be the limit of this function equal to? The answer to the question, as x approaches 3 from the left hand side, the function approaches this value. I can approximately take it as 2.2. And when it approaches from the right hand side, again, it approaches the same value. So I can say that the answer to the question is 2.2. Limit of the function as x approaches 3 from the left hand side is -1. Okay, so the answer is that's true. As x approaches 3 from the left hand side, the function does approach -1. How do you write this? So limit x tends to 3 minus f of x is equal to -1. Then as it approaches 3 from the right hand side, here you can see that it is becoming equal to 2. So this statement is also correct. So here you have tends to 3 plus and it is 2. Are the two sides different? The answer is yes. So the left hand limit is not equal to the right hand limit. So limit of x tends to 3 f of x does not exist. So I'm repeating, individual limits exist. That means the left hand limit exists and it is equal to -1. The right hand limit exists and it is equal to 2. But they are not equal to each other. So the limit does not exist for the function when x approaches 3. Okay. But if the question asks you for this, then you should write -1. You shouldn't write does not exist.